Hey, so I'm super happy to have finally found some time to share this tutorial with you, and I will be showing you how to use BITBYBIT Runner. It's a technology that allows you to use our visual programming scripts in your own websites and host them on your own hosting providers. And for that, I will be using StackBlitz. So you can use CodePen if you prefer that, or JSFill, or you can just create the website yourself. I don't know, maybe using VS Code or some other editor. So let's get started and let's see how BITBYBIT Runner can be used and how you can leverage its features. We have prepared a very small project here that contains no code. You see that this HTML is completely empty. The JavaScript is empty. CSS for styling is also empty. So in this case, we can just begin coding some stuff, and let's get started with including the BITBYBIT Runner JavaScript file. So we do that by creating this script element with a source that points to this CDN link, and let's close the script like that. So with this JavaScript file, you gain access to BITBYBIT and all of our algorithms. You also have the possibility to just use Babylon.js and physics engines and OpenCascade technology kernel and all that by including this single JavaScript file. This file is hosted on the CDN of JSDeliver through the GitHub. So you see that we use our BITBYBIT assets repo, and we have this version here. So if you open the BITBYBIT assets GitHub repo, you will find all the releases here, and you can click on all of the releases and find them here. So this is quite convenient. If you get a new version, you can just check it here and update the version that is in here, and that will give you all the latest features of BITBYBIT in your own websites. Okay, so now that we have this, we are prepared to do more work, and we will just write a few lines of code here to create a div that contains class myCanvasZone, and we will also create a canvas on which to render our 3D environment, right? So this is quite familiar to you if you use 3JS or Babylon.js. This is what you do a lot. So let's do this, and let's call this my canvas, and let's hit save. Okay, so our HTML page doesn't change a lot, and that's because everything is just white, right? So let's include some styling, and I will just say that the body contains some standard CSS that I have prepared here, and it will get this background color. The text will be white. We will use IBM Plex Sans font for text, and we will not have that much text in here. And we will also give an offset of the canvas that will be 20 pixels from the corners of the body. Another thing that we will do here is we will just say that we have my canvas style, and I'm gonna bring some styling with it here so that we see it better. Where is this canvas? So the canvas now is within this border, right? So this is quite nice. And let's hit save. Okay, so now that we have this, we can go ahead into our script file and just do some very basic setup for the runner. So let's get the runner, and let's call it runner, and this will live under BITBYBIT runner and get runner instance. So another thing that we will do is we will create a timeout function, and this is required to let the HTML render correctly on the page, because now we will want to also access the canvas, and if we don't use the timeout, and it is in essence is a timeout of 0, if we don't allow the browser to refresh, then we will not be able to use the HTML canvas that we've just created. And we want to do that. We want to pick it up in JavaScript. So this is why we need this timeout function. And to make our life a bit easier, we will also say that this function will be asynchronous. because BitByBit runner creates a lot of stuff asynchronously, and this is then very useful. So let's go ahead and let's say that we have runner options that contains some default properties, which I will just copy paste now as well. So canvas ID, we already have it here in the index HTML. So this is in my canvas, right? This is the element that we will be using. Zone is selected by the class, and we provide that as well. We say that we will enable physics. Yeah, that's not really necessary for this tutorial. We will enable OpenCascade technology kernel, and that's fine. This is what we want. We will be creating cube in Read editor that will be using OpenCascade. We will not be using JSCAD in this tutorial. And to test if it works, we can just say runner.run, and let's use our runner options as an input. And now you see that we've created the white background on the canvas, and that's sort of hello world of BitByBit, because it comes from this background color here. So if I say that it's 0000, then it will be blue. And it just means that communication with the BitByBit runner works, and it also means that this script picks up the right things, right? And it can then render already something on the go. So it's interesting maybe to also point out that by awaiting on the runner, you can also get stuff like BitByBit, you can get the bit, and these are all the things that you are maybe familiar from the TypeScript environment in the BitByBit editor Monaco. And it makes also life easier if you just want to code stuff directly in your website through BitByBit. But this time, it's not exactly what we will be doing. What we will do is we will be executing scripts from Read editor, and for that we use runner execute script command. And this takes two things. So it will take the script itself, and it will take inputs as an object, as a JSON object. So for now, the inputs are empty, and the script is empty, and we don't have anything on this canvas. But let's change that. Let's go into BitByBit, and let's open up the Read editor. And let's just create a very simple thing. Find shapes, solid, and let's create a cube. So this is a single cube on the website that we can export to the runner. This is what we need to click to generate JavaScript code. We can then hit this copy button, go here to the StackBlitz again. Then instead of this, we will copy paste this script, and voila, you have now made the communication happen between the visual editor on the Read side and your website on StackBlitz. And these are completely two different websites, right? So this is quite cool, I think. And while this contains some code, you don't need to really worry about it. You can also save that code as an asset somewhere and load it as a file, and then parse it, and then sort of recreate that environment. So this is all up to you, but we will just use these scripts inline. That will make our life a bit easier for this tutorial. And I will just abstract it into the function. So let's call the function get inline script. And this function will return this script so that we don't need to, have this directly in our faces here. And now let's hit save. You see that it still works. We execute the script and we provide empty inputs. So, okay, now that we have this, we can move further. We will make this script react to the input that we will be sending to the script of Read. So we will need to change this script, and also we will need to change stuff here, how we execute it, and we will just say that we have async function called change size. we will accept the size as an input here, and we will be executing this script like that. And we will say that the size is being passed as an input to the script. So now on StackBlitz side, we sort of solved it. And let's say that we are sending 1. So currently, if you change this size to something else, you will see that the cube doesn't adapt. And that's because there's no one in this script listening to input values. And let's change that. So let's do something like this. Let's go to the runner category here. This is very important in these situations. And let's say that we want to get runner input value. This is the component that we will use. And let's say that we are expecting to receive size input. And let's bring that size over to the cube. So this is it. Now, if we hit export to runner, we again click copy. We go here, we select this script, we remove it, and then we paste our new code. And now you see that the cube looks quite a bit bigger on the screen. And if we change it here, so we just say 3, it will be smaller. If we say 1, it will be even more small. The thing is that every time you change this number, StackBlitz will reload your website, and that's gonna execute your code again. And this sort of feels interactive, but if you would have your own website, you would need to click refresh each time to get the same effect. So if you change that number, on your own static website somewhere in VS Code, you will probably need to reload this button. Or maybe you have a setup that does that automatically for you as well, if you're into React or Angular or some other framework. Okay, so this time we have some basics that are working, but what we also want to do is make sure that we can control the size through the input. So we will create a new HTML element here, and we will say that we have a label. And label will be for size ID of input, and let's close the label, and let's say that the label is named size. So this is the text, and now we will create an input. We will close it. We will say that its type is number. Its value will be by default 1. Its ID, and that's maybe something I should do in the beginning, will be size. So this size and 4 should match, right? So if you click on the size, it just focuses this input element. Another thing that we will do is we will provide some boundaries for this input. So the minimum value will be 1. The maximum value will be, 10 maybe. Step will be 1. So now that we have this, we see that we have this input element, and we can click on these arrows to increase the size. The only problem is that currently there's nothing that is being executed when this value changes. And to do this, we can just say on change, and let's execute change size command. And let's say that it will pass event target.value into it. So if you know JavaScript, you'll know that this is a sort of default way how to handle change events in HTML. And event target is the element of input, and its value will be the current value of what you see here. So if it's 2, it's 2. So only problem now is that this change size function is not really globally accessible to HTML, and that has to change. So we have to just do a small trick and say that window.change size is change size. Basically, we will add this function on the window object, and window is globally available, and that will make it possible to just change its size. So now we also need to change this from 5 to 1. Hit save. So now when we have this and it matches the number, we can hit this arrow button, and you see that the cube is increasing in size. And I can rotate it here, and I can click up, 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 and it will just go till I reach this maximum value of 10, and then it will not increase anymore. But the only problem now is that if I decrease this value, you see that the cube remains intact. It remains visible. And that's due to the fact that every time we execute this code, the cube is recreated and the old cube isn't being deleted. That's a standard problem that you may face, and we have a solution for that, of course. So how do we solve this? Basically, there are a few ways to do that, but maybe the most simple one will be through use of draw command. So in BITBYBIT read editor, we can use this draw async command to create a mesh, and we will have to return that mesh as an output from this script. So you can also find the draw component here by clicking this async function, and you can also configure the options of the drawn objects. So if you use it like this, so you will say that you want to draw a cube, and you will use these options. It will of course look the same because you use the face color of the same object. The only thing is you need to then hide the object that is produced by this component for visualization purposes. And now you can just change the color to something like blue. That's quite cool. So let's look into this here in the read editor. And now the important part is to return this mesh as an output to the runner. Let's use this command, set runner result value. And let's call it cube mesh. And let's just attach this value here. And let's hit export again. Let's hit copy. Let's go into StackBlitz, select this whole text, paste it here. You see that our cube turned blue now. That's quite nice. And the thing is that we now need to pick up this output value, and we do that through the use of JavaScript. So this is how to get the output of your execution, and we will use a trick, and we will create previous mesh object that is by default empty. We will say that if previous mesh after executing the script is defined, then we will dispose it. And we will also say that after execution happens, we will assign the previous mesh to the cube mesh that we output in read editor. So we told that the output property of the result will be cube mesh. We pick it up here and we attach it to the previous mesh variable. So each time this code executes, the previous mesh will be disposed and then attached again to the new mesh, right? So because of that, we will be able to see how cube changes not only when we increase this value, but also when we decrease it. So now we don't create multiple meshes, we create one, and that is being adjusted like that. So this is quite cool, but it goes beyond that, because now we simply created a very basic script here, and that is all fine. But what we can also do in BITBYBIT, of course, is do more things, like you can fillet edges of this cube, for example, and then just say, okay, I want to fillet, I want to hide, I don't want to draw this anymore, but I want to draw a new result. And you can see that maybe your fillet is of 0.4, so you create this shape, right? And you don't even touch, any JavaScript code in here. You just code things via those simple components, and then you just hit export runner, copy, go back here, paste it here, and voila, you get your new script. So you didn't change anything in this code base, but it just works. And if you increase the size, you'll see that the code executes again and the fillet is becoming sort of smaller because the cube is getting larger. So this is also quite cool. And if you go back, it also works. So this cube is a very, very simple example of what is possible in BITBYBIT, but I think for this tutorial and for this purpose is very good, because it's easy to see how everything works, how, you know, simple mesh is being returned, how inputs work with BITBYBIT-RUNNER. And yeah, we will leave more complex things for later tutorials. So I hope you guys will subscribe to a BITBYBIT channel on YouTube. And yeah, let's see each other in the next videos. Cheers.